Welcome. My name is David Malin, and this is CS50. And this is not your typical high school computer science course. This course is a little something special. And that's not because I'm teaching it, but because this is one of, we like to think, those rare courses that actually squeezes your brain so much and your schedule so much that by semester's end, you genuinely feel smarter. So that was the way I felt when I myself took this course back in 1996. I was a government major at the time, here living in Mather House, and as are the five others here. So I was a government major at the time, and I was a government major because I had always liked history. I'd liked constitutional law in high school, and so I set off on this path freshman year, doing what I knew best, doing what I knew I liked. And yet I'd always been a bit of a geek. I'd always dabbled with computers, but I myself, perhaps ironically in retrospect, always viewed the guys who were taking computer science in my high school, my friends, as the real geeks. And yet finally did sophomore year, I take this little course called CS50, which actually had scared me away my own freshman year. And I was a user assistant at the time. So I was certainly already qualified, at least, to be among those geeks who I made fun of in high school. But I was scared. It had this reputation at the time, and perhaps still in part, that it was a scary course. It was a lot of work. It was hard, and yet it's one of those things where, my God, the bark was far worse than its bite. I found myself sophomore year for the first time actually finding homework fun. And I'm not saying this just to pitch this course to you. This was a genuine realization for me. Now, I think at one point I did cross the line to true geekdom, where I actually used to look forward to Friday nights because I could curl up in front of my little MacBook and work on CS50's problem sets. So at that point, I think I had clearly crossed the line, and our goal in this course is not to turn all of you into that person, but just to say that there's a little something special about this course, a little something special about computer science in general, especially these days. So the more acclimated we've all gotten to technology, the more toys we carry around in our pockets that are themselves computers. I mean, my iPhone is actually a higher performing computer than my laptop was in college. You can do a lot of neat things with these things. And now most of us in this room probably just use other people's software, other people's tools, other people's solutions to problems, because we go to iTunes, we download some app from the App Store, and voila, we can do something really neat. But by the end of this semester, you can be the person doing that problem solving. You can be the person solving some problem, building that app, that piece of software, that tool that either one, just amuses me, amuses you. For instance, controlling, say, your iTunes library from within your apartment, clearly an app that already exists. Or you can find shuttle schedules more easily, for instance. So in fact, one of the very first things I did after taking CS50 was, again, it was probably at this point Friday nights and Saturday nights, there was this opportunity at the time where Harvard was running shuttle buses, and to this day they still have these printed schedules, but there was really no means online of finding out when the next shuttle was. Now, I didn't care, because even though I lived in Mather, I wasn't among those who generally took the shuttle, but I had a lot of friends in FOHO, for instance, and one of them asked me, I think at one point, okay, FOHO is better than Mather apparently. So one of my friends kind of got me thinking, maybe I can write a little program to help my friends check the shuttle schedules. And thus was born the awkwardly named Shuttle Boy, this piece of lexicon that has stayed around for some number of years, at least among some of the upperclassmen. At the time, this was this little command line program, similar in spirit to DOS. It was running in a Unix environment, so it wasn't very sexy at all. You just typed a couple commands, and it told you when the shuttles were. Well, these days, it's a little more sophisticated, and it's actually representative of precisely the types of projects that students in this course end up making by term's end. So this is version 4, some 15 years later, of Shuttle Boy. It seems Google Maps is being a bit slow there, but for those of you who have to get out of here after class and go, say, from Memorial Hall and need to go up to, say, the Quad, well, you can either leave in 2 minutes, if this really isn't working for you just yet, or you have as many other options as you might like. And coming soon, we can pitch this from CS50, will be the same capability via SMS. You can text Shuttle Boy. Via phone, you can call Shuttle Boy. CS50's phone number this year will, amazingly, this was available, 617-BUG-CS50. So that will debut soon. Don't call it just yet, because I've gotten reprimanded for right now. It's being routed to our assistant head teaching fellow's cell phone. So you'll just get him if you have questions about the shuttle schedule for now. But that will soon be implemented. So other things actually that we ourselves spent this summer on, really in preparation for this semester, was a whole bunch of other problems that we wanted to solve. So for instance, there's a whole lot of stuff that goes on this campus on a given day. And in fact, put another way, there's a whole bunch of stuff going on at this campus that I certainly never take advantage of. And even though I am now overwhelmed with how many things that are going on campus, I still seem never to find the time. But voila, even there, CS50's lecture, that's where you is. So this was a program we wrote to aggregate all of the events on campus. And this has been something that other students in this same course have tackled on their own. And we've been working with other entities on campus to really make this happen. But the point to CS50 this term is that all of these little programs we've been working on, whether this one or whether one for aggregating all of Harvard's news in one place, a la Google News, all of these things are going to have what are called APIs, application programming interfaces. And this is just fancy speak for the capability of letting other people in this room, actually doing something with that same data. So by term's end, if you decide to implement a final project related to news or events or maps, well, we at least as a course will make that all the more easy this year by providing you with an interface, a set of functions, so to speak, software that you can use in your own projects to go above and beyond where students perhaps have gone in terms past because this framework has not been in place for them. And again, this all began, for me at least, some 15 years ago, implementing Shuttle Boy. I then emailed my friend Ken in FOHO. I said, hey, what do you think? Is this useful? He emailed it out on the FOHO open list. And voila, all these years later, I'm apparently still milking this project. But the neat thing about it, and this is where, too, a course like this in engineering and computer science is, I think, a little special, is that when you do your homeworks and when you do these projects in this course, many of them, yes, you'll put aside and not really use again, but some of it you will. And there's this really powerful thing, at least for me, this really exciting thing when you make something and other people actually care. Other people don't just smile and pat you on the back and then sort of go about their own lives. They actually use what you made in their own lives, even if it's for something as silly or as simple as just finding when they can get out of here to catch the next shuttle to the quad. So by term's end, that's one of the goals for this course, to empower you guys to just identify some problem, whether it's on campus or hopefully well beyond campus, and actually use your own skills, your own mind, and solve that problem in some part technologically. So this is also a course, as we say in the syllabus and in the course's official description, that teaches you how to think, and it teaches you how to solve problems more efficiently. Well, what does that mean? Well, when you've got 600 megahertz in your pocket or 3 gigahertz under your desk at home, you can solve a lot of problems efficiently just by sheer brute force. But there's a lot of problems in this world, whether it is searching, say, Facebook's network or the internet via Google, that it doesn't matter how fast your particular computer is. There's no way in hell you're going to search billions of web pages quickly unless you actually approach this problem intelligently. You don't just search, for instance, a huge list of all the web pages on Earth from top to bottom looking for something related to whatever search terms you're looking for. Hopefully Google, and presumably Google, and Facebook, and any of these large entities have a lot of smart people thinking about how they can find data more quickly, how they can process information more efficiently, and how they can just generally return results more quickly so that you can do yet more interesting things with these devices. And so what do we mean, though, by teaching people how to think more carefully, more algorithmically? Well, this little visual always seems to go over well, and it seems to be memorable. And I was even asked just yesterday by a former student, oh, are you going to do the phone book thing again? And I pretty much on the spot decided, all right, sure, we'll do the phone book thing. And he asked me, when you tore it in half, right? I was like, well, yeah, technically we tore it in half, but not in the way, in the computer science way, will I be able to tear this thing in half? And so here was the problem that we've presented for some time. So here's a phone book. It's got at least 1,000 or so pages. And the simple goal at hand, very real world, is to find, say, a person in here. So Mike Smith, last name starting with S. So I'm a typical human. I pick up this phone book. And anyone out there, what would you, a typical person, do to start finding Mike Smith, obviously not knowing in advance what page he is actually on? All right, so you go roughly in the middle, right? And at this point in the story, I'm probably in the M's or N's, roughly halfway through the phone book. Turns out the last time I did this example, I somehow found myself in the escort section. So it's actually not equally balanced between A through M and N through Z. But today we are, in fact, in the M's. All right, so now I'm at the M's, but what's my takeaway now, just as a normal human off the street? Where do I go next for Mike Smith? All right, so he's probably on this half, right? Because S comes after M. And so herein lies the visual drama. So it's not really tearing it in half, right? I kind of cheated down the center. But we now know that Mike is at least not in that half. We can literally throw half of the problem away, and I've left with a problem that's fundamentally still the same thing. Find Mike Smith in a really big book, but the problem is now half as large. If it had 1,000 pages before, now it's got 500. You know what? I can do the same thing again. I can kind of recursively or repeatedly do the same thing. Now I'm not quite at S, I'm at T, and so, oh, I went a little too far, but I know now that Mike is not to the right. There's going to be some class someday where I just can't tear the damn thing, I bet. But now I know he's not to the right, so now the problem has been quartered. So I've gone from 1,000 to 500 to 250 pages. And again, if you continue the logic, continue the mathematics, I'm chopping this problem in half, in half, in half, until finally I'm either going to not find any Smiths at all, unlikely, or I'm going to find the one I'm looking for. But that then begs the question, is this any better than the simple approach of just saying, you know, A, no, B, no, starting from left to right, going linearly through the book? Well, instinctively, yes, it's going to be a lot faster. But how much less? Well, if I have a 1,000-page phone book, or maybe, let's say, 1,024, for those of you who like powers of 2, well, how many times might I have to split this problem in half before finding Mr. Smith? So 10, right? If you have 1,024 pages and you split them in half and half and half and half, I do that 10 times, which means I go from 1,000 pages to the person I'm looking for in just 10 page turns. Now that's kind of neat, but you know, if you think about it, you've been doing this all of your life, not that dramatic. But now suppose the phone book isn't just for Boston, it's for the entire US or the entire world, and this thing has billions of pages in it. Imagine a phone book with 4 billion pages. How many page turns am I going to have to do maximally to find Mike Smith in a 4 billion page phone book? Now, so yeah, if you're kind of right, the math type is this is log base 2, but if you think 4 billion to 2 billion to 1 billion to half a billion, I mean, that actually whittles itself down pretty darn fast. And in fact, within 32 halvings of the phone book, even from 4 billion, I'll get down to 1 page. And that's when this stuff gets powerful, I think. That's when these ideas get compelling, when you can have a 4 billion page problem, and in 32 steps, you can find the person you're looking for. And so that's what we mean when we say that you'll learn how to think more carefully, more algorithmically, more intelligently about solving problems. And the returns are huge when you can actually do this. And again, to this point of the Googles of the world, the Facebooks who have the luxury of having huge data sets, you've got to approach these problems in this way. Otherwise, it's simply not going to work. Well, what did this student actually recall I do? We like to do things that are a little bit silly sometimes to sort of take the edge off of what is otherwise a lot of new material. And so he actually, this former student, sent me this link, which I went ahead and just for kicks and then regretted it at the end, pulled up on YouTube here. So I thought I would share what a non-computer scientist means when he tears a phone book in half.
Back, we're going to get into some legitimate phone book ripping. A lot of the guys, they trick you into think they're ripping phone books by folding it and then bursting down on top of it, which is called the popping technique. And I basically rip phone books just with legitimate grip stick alone. So let's give it a try. Go, 1,500 pages, nice clean line, legitimate tear.
So I suppose his way works too. So what I got out of this course all those years ago was, yes, Shuttle Boy, and then yes, a degree in computer science, and then yes, a PhD in computer science. And that's not what we're trying to turn most students in this course into. Most of you in this course are not going to go on and major in computer science. Some of you might minor, but for some of you this will be a terminal course. And that's perfectly fine, because this course is in fact structured in a way where even if you just pay your dues for several months and you really focus in and you really take as much out of this course as you can, you will, in fact, be well equipped to go back to your world of economics, biology, psychology, applied math, and actually make use of what is ultimately as interesting a course, we hope conceptually, as it is fundamentally practical. And that, too, is something that's perhaps a bit rare to find. I thought I'd share a few comments that students from last fall put in this past year's Q guide when asked about what would you like to tell future students. Well, if you haven't already looked at these comments, one student said, this course will take a fair amount of your time up, but if you put your work into a whole new world, if you put the work into, all right, so this is his grammar, not mine. So if you put in the work, a whole new world will open up to you. Amazing how much I learned in only 12 weeks. Another student wrote, you better take this or you're going to regret it. Another wrote, a little more bluntly, it will kick your ass and leave you feeling great. And then finally, this one is perhaps something I can only show in writing, but second from the bottom here. So I'm not sure if you have many friends who took this course, but we kind of did a lot of damage to last year's students. We introduced at the start of several lectures, a few quizzes, a couple problem sets, this notion of lolcats. You can't see what I can see here, but in a moment you will see a young man named Happy Cat, who is the leader of the so-called lolcats. This is one of these stupid internet forwards that I think, frankly, the dichotomy between these two gentlemen here and what we now have this on the screen is perhaps one of the most inappropriate uses of this theater to date. And why don't we make a little more real, a little more personal, this notion of actually solving a problem more efficiently. A simple problem on day one of any school is to sit down or stand up and start counting the students, right? Roll call of sorts. Well, the most naive but nonetheless very correct approach that I, a teacher, could take is 1, 2, 3, 4, 5, 6, 7, and we'd be here quite some time. So what's a marginal improvement on this, even that you might have done as a kid? How do you count people faster? And don't start reading off my own instructions. What would you have done as a kid? Start counting in twos, right? So I'm pretty good at 2, 4, 6, 8, 10, 12. So that's something interesting, right? Now, how much of an improvement is that there? So it's obviously a factor of 2. It takes me half as much time. But you know what? As we'll find throughout the semester, big deal. Like speeding up your running time by just a factor of 2 is not all that interesting, because if the analog here in the computer world is that I'm a CPU, I'm a computer, well, heck, if I just wait 12 months, 18 months, I, the computer, will just be able by nature, by the number of gigahertz I have in me, to be able to count people in this room faster. So these kinds of linear speed ups, like factor of 2, factor of 3, even factor of 10, who cares, right? We can throw hardware at that problem. We can wait things out. We can develop faster machines. But intellectually, yeah, that was kind of clever, but it didn't really fundamentally change the problem. I'm still going from left to right, front to back. It's really the same algorithm. But I offer that we can do better. We can do smarter than this and do fundamentally a faster implementation. But to demonstrate this, we need you to humor us for just a moment. And it's at this point where it'll be me talking less and you talking more, but I do need you to execute step 1 together, which is, if you would, humor us, please stand up. The directions here on the board, you now are, okay, a couple of you have to sit down. Those of you in back, there we go. All right. Thank you. The program here is before you. You are now the computers executing this program. It's fairly self-explanatory at this point. Yes, you should be number 1. Get it, right? Many of you are probably thinking this already anyway, freshman year. So think to yourself, you're the number 1, so step 3 here, pair off with someone standing, add your 2 numbers together, and adopt that sum as your new number. And we'll do a sanity check. Do you know how many we have? Do you know where Jansu is?
No, she might be out cutting the cake. Do you want me to get her?
We need to have an answer key.
Yeah, sure.
At this point, the algorithm should be winding down.
One of you is 150.
Maybe we should have gone with my approach after all.
163.
Ooh, arithmetic in front of 300 plus people. What's our final tally going to be?
386.
386, and are you the last one standing? Is that everyone? Do you know what the answer is? Do you know what the answer is? We didn't bring an answer key with us. So 386 is in fact precisely the right answer for the first time. That's okay. Very nicely done. So what was the takeaway? Because that definitely felt a little slower than my very simple, but nonetheless very correct approach of just going onesies and twosies and just getting it done with from left to right. But what did we really just do there? Well, if there were roughly, let's say, 400 of you standing at one point, and then half of you, very quickly from what I could tell, wanted to sit down. So half of you sat down. We went from 400 to 200, then to 100, then to 50, then to 25. So again, there's that same divide and conquer idea that we had with the phone book. Again, with every iteration, we halved the size of the problem. We halved it. So in theory, your algorithm should have been much faster than my linear approach, because my approach would have taken, say, 400 steps, or maybe if I'm slightly clever, 200 steps. But yours would have taken far fewer, right? From 400 to 200, 150, 25, 13, 6, so fewer than 10 steps in the end versus my 200 or 400. And there's the germ of a really interesting idea. And yes, mathematically, what you just did was something that's a little logarithmic in nature. By log base 2, we divided in 2 and 2 again. And we'll revisit this later in the semester. But therein lies, again, a very intelligent implementation. And we are just scratching the surface of the very clever, the very intelligent, efficient approaches to problems that we might ultimately solve. So who are the people you just chatted with, if briefly? A common concern in a course like this is that everyone to the left of you and everyone to the right of you must clearly know more than you. Well, that's absolutely not the case. And in fact, in recent years, this course has made a concerted effort to reach out to those less comfortable, so to speak. And by that, we mean not people who have never touched a computer before, because that's really hard to find around here these days, but folks who use email, use Facebook, maybe even right now, but are not necessarily quite sure what to do when something goes wrong, or when they are asked about anything technological, you know, the hands go up, or they kind of push the hardware to a friend who's perhaps more versed in it than they. Well, these are some statistics from last year's semester. So when we asked our 400 so students last year, you know, what is your level of comfort coming into this class? Well, 34% wrote themselves down as among those less comfortable. So if you have come into this room and are still thinking now that, you know what, this term less comfortable describes me, know that you are in very good company. But realize too, if you're coming into this course with the backgrounds in AP computer science, and you were really that geek in middle school and high school who was writing code and teaching yourself languages, well, that's fine too, because there's definitely a non-trivial sized audience with that background as well, about 13% last term. And then there's everybody else, sort of someone who doesn't think they're less comfortable. They definitely don't think they're more comfortable, but they're just in a course to get something out of it. So realize that this course does draw quite the spectrum of students. And to put this in more concrete terms, 71% of students last year had 0 courses behind them. So if you're entering this course thinking, oh, everyone who takes CS50 was a computer science science whiz in high school. It's not the case. Most people are presumably just interested in it. And a few, yes, absolutely have taken some courses. Some, at least one person last year had taken 5 courses previously. So we definitely have some outliers. But again, the meat of the curve is in those lower values altogether. And another interesting statistic we shared over the past couple of years is the gender ratio. So historically, at least in computer science, there is a bit of a male-female skew. A couple of years ago, it was much more marked than last year. So we're almost now at the 40% level. And if I can throw down a gauntlet just for the sake of having a third pie chart next year that's even more equitable, I would point out that there's absolutely no reason from the course's perspective that males and females shouldn't be enrolling in this kind of course in relatively equal numbers. And realize, too, 38%, 48%, we're actually quite pleased to see that we're almost at that, at least statistically even value of 50%. So if you are, in fact, female, do rest assured, too, that this is not, in fact, a male-dominated class. Well, this just so happens to be CS50's 20th birthday. Well, thank you. That's very nice of you, because we brought cake for you, actually. And so when you exit here later today, you'll actually get a chance to meet many of the course's teaching fellows who will be lingering in the hallway. And yes, it'll be a nice sort of incentivized way of meeting the teaching fellows. But we did take a trip up to a little bakery. And again, consistent with the course's playful nature, while nonetheless expecting a non-trivial amount of work while we're having that fun, well, we do have one of these cakes for you. So if you're laughing, that's actually good, because even if you're among those less comfortable, you're at least aware of it. Those of you in the 14% might prefer this flavor. And then if you don't know what the hell is going on right now, we also have this for the rest of you. So those are being chopped up into pieces outside as we speak. So again, let's take things up a notch and at least introduce some basic tenet that we'll then take for granted in the remainder of the semester. So we all probably know that computers ultimately boil down somehow to zeros and ones, these things called bits. What does that mean? Well, you can think of it, frankly, as a light bulb. A bit is a light bulb. It's either on or it's off. It's a switch. It's either on or it's off. Now, computer scientists generally think of off as the number 0 arbitrarily, and the notion of on as 1. So if you throw a light switch on, that's a 1. Turn it off, that's a 0. Or equivalently, turn the light on, that's the value of true. Turn it off, that's a value of false. So these are just synonyms. But at the end of the day, yes, all computation, all stuff that goes on underneath the hood in a computer does ultimately boil down to zeros and ones. And when you stop to think about it, it's pretty damn remarkable what the world has done with these basic building blocks, including some of the devices you're holding in your hands. Well, why are zeros and ones useful? My God, even in the real world, we at least have 10 digits, 0 through 9. Why so limited? Well, in hardware terms, it's very easy. It's much easier to represent 2 states, right? If computers are plugged into the wall usually, you kind of have this easy source of binary nature. It's either on or off. Electricity is flowing or it's not. So that's kind of one of the initial reasons that the world went with just zeros and ones in computers. But you can use them as building blocks. So this actually is a little small on the screen here, but we can count in binary. We can represent anything we want in binary, just as we can, say, decimal, just as we can even, in fact, with alphabetical letters. And so here's the quick system. In just a couple minutes time, you'll now know how to count, how to write, how to speak binary, much like your own laptop. Well, you have in the world of binary, sort of just like grade school, columns or values. So in grade school, we learned this is the ones column, this is the tens column, the hundreds columns, and so forth. In other words, y is the number we know as 123. The number 123, well, my teacher taught me this was the ones column, this was the tens, this was the hundreds. Well, what did that mean? Well, to figure out what the total value is of what is otherwise this string of digits, just hash marks on the board, well, we have 100, so that's 1 times 100, and then plus what? 2 tens, so that's 2 times 10, plus 3 ones, so that's 3 times 1. And OK, so I seem to have gotten back where I started, but this very simple process of just multiplying the digits by the value of the column is exactly what binary is all about. But in binary, you use powers of 2, not powers of 10. So here's a series of 8 light bulbs. Computer scientists like to use values like 2 and 8 and 16 and 24 and 32 because they're all generally convenient values to use. So when we talk about 8 values in sequence, this is that thing called a byte. And these days, we rarely talk in just bytes. We talk megabytes, gigabytes, even terabytes these days. But it's all ultimately the same thing. Here's 8 bits, aka 1 byte. Just simple jargon. So all of these light bulbs are off. So the math is actually really easy. So there on the right, because though it's small to see, is the 1s column, the 2s, the 4s, the 8s, the 16s, 32s, 64s, 128s. Right? Maybe it's hard to memorize at first, but it's just multiply by 2 from right to left. So you can always recreate this. Well, they're all off, so that's 0 times placeholder, 0 times placeholder. So this is the number 0 represented in binary. In other words, how do you write the number we know as 0 in binary? Well, 1, 2, 3, 4, 5, 6, 7, 8. And technically, just like in decimal, all of these leading zeros, they don't add anything to the formula. They're just there because we arbitrarily decided we want 8 of these things in a row, right? If they're physical objects, we have 8, so they've got to all be off. But we could have just gotten away with 1 0. Well, how do you represent the number 1? Well, instinctively, you're going to throw one of the switches. You're going to turn a bulb on. So there is the number 1, because we now put a 1, a light bulb that's on in the 1's position. How are we going to represent 2? Well, we actually have to throw 2 switches now, at least versus this state. We have to turn on the 2's column, turn off the 1's column. And now we have the value of 1 in the 2's column. So that's the total value of 2. Now, a quick mental exercise. What's going to happen with the next sequence? How do I present the number 3? Well, I need 1 from the 2's column, 1 from the 3's column, and aha, so now I've incremented that one, and now this same basic pattern repeats. What's the number 4? Well, let's see, I just need a 1 in the 4's column, and then 0s in the 2's and 1's, so then it continues in that way. And it's just this sequence of steps. So the notion of binary is really not all that complicated. At the top there, we have 8 zeros. Below that, we have 7 zeros and a 1. Below that, we have 6 zeros, a 1, and a 0. And that's binary. Now, thankfully, we, computer scientists, you programmers by term's end, are not going to often be writing in binary, talking in binary, thinking in binary, because we've built many layers of abstraction on top of that. In fact, people rarely talk about bits, except in a networking context. They talk about bytes, because 1 bit, not that useful. 8 bits, these days, still not that useful, but at least 8 bits, 1 byte, is at least getting us toward more useful units of measure. But when we start looking underneath the hood, when we do certain problem sets and look at files and look perhaps at network traffic, it will become interesting to know how you're representing data, because you're going to have to figure out how to display that same information. And in fact, if we only have 0s and 1s, how do we go about representing, say, alphabetical letters? Well, we're going to have some mapping between binary and letters, but that's as of yet unclear. But to hammer this point home, and to give me a break from speaking at, I thought I'd pause for a moment and see if we can't recruit 8 volunteers. 1 byte, 8 people. Can I get 8 people for whom it is not too awkward to come on up? Good, good. 1, 2, 3, 4, 5, 6, 7, 8. Very enthusiastic 8. Come on down. So you all, for just a moment here, oh, and you have to be willing to now be on the internet, because there is, in fact, a camera in the back of this room. So turn back now if you don't want to be on the hello, Mom, in perpetuity. So let's see. You here will be the 128th column. And let me ask that you simply hold this before you. And actually, if you could scooch this way just a little bit, then I will get out of your way. You'll be the 64's column. You shall be the 32's column and the 16's. 32's, 16's, 8's, 4's, 2's, and 1's. All right, so perfectly lined up with the placeholders from before. But we need a little bit of mapping. So a quick setup. We just need an arbitrary way of mapping binary numbers, which really can be converted very easily to decimal numbers. So we need a way of converting numbers to letters if our computers are actually going to show us emails or let us type URLs or actually display non-numeric information. And in fact, there is a system for that. It's called ASCII, an acronym that whose meaning is not so interesting, but whose utility is, this is just a mapping from letters to numbers. And there's actually a lot more numbers on the screen. And you guys, don't worry, aren't going to have to test yourselves with this in just a moment. But there's a mapping between numbers and letters. And I'm just going to get us started by pointing out a couple of these. The numbers of interest right now are going to be, this. Whoops. So in this column here, I can't seem to zoom in simultaneously, we have decimal, dec for decimal, and then we have the character on the right-hand side. So if I hop over into this column, though it's a bit small on the screen, the number 65 represents what letter? capital A. And the number 97, lowercase a. All right, so with those two alone, right? So do not go home and try memorizing ASCII chart. Come quiz time. Do not try memorizing an ASCII chart. Memorize 2. 65 is capital A, 97 is lowercase a, and from there can you bootstrap yourself to all of the other alphabetical characters. But all this chart says, and I just downloaded this chart from ASCIItable.com. This is a standard that's been around for many, many, many years, but most computers still use it. What we now have is a means of encoding alphabetical information using what's ultimately numeric. So if these guys are just switches, light bulbs, computers, we can actually convey messages. So each of you has some hints on the back. We're going to have 3 rounds here where these guys are going to spell out in English, in ASCII, a very short message, a 3-letter word. It will involve them either raising their hand, thereby representing a 1, or just standing there awkwardly, thereby representing a 0. So why don't we proceed immediately with round 1, and you can either raise or not raise your hands. So the audience doesn't get off the hook. What number, first of all, are they currently representing? 66, right? Not hard because we have a 1, a hand up in the 64s column, a hand up in the 2s column. 64 times 1 plus 2 times 1 is 66. They're representing the number 6, which means the first letter is B. So not too bad. All right, round 2. First letter was a B. Can someone second that? Yes. All right. So 79, which means it's now an O. So B. OK, B-O. There's a 3rd letter. Actually, that is kind of, yeah. 3rd round. 3rd and final round. What number is this? I heard an 87. Someone else agree? All right. So yes. So this is, in fact, 87, which maps to. And this is the very clever setup, at which point you all B-O-W is bow. Very good. So actually, besides that little souvenir, that was not a very enthusiastic applause, so I'll take care of you. So we do have a little something for these guys here now that they've just appeared on Sanders' stage doing perhaps the geekiest thing they could. So maybe if we could humor them, if only because I'm feeling a little awkward now, a little round of applause for these guys here. Thank you. Do you want these back? No, all yours. All right, thank you very much. So it turns out that we can take this one step further, right? You are now entering a community of people who understand things like this. It's slowly spreading, yes? It's not cool that you understand this now, right? So we've already done some damage here today. But yes, there is now such thing as geek humor that you might at least catch a little bit more onto. So what are we going to do throughout this semester? So there's 12 weeks, 0 index, so 13 weeks in total. You'll find throughout the semester that computer scientists tend to count starting from 0 for reasons that will soon become clear. But what we're going to do this week, starting this Friday, is introduce you to programming. Now, you may already be coming at the course with a background in the same, and that's perfectly fine. But we'll also be able to introduce some more sophisticated topics than are typically covered. Things like events and threading. So just to toss out a couple of buzzwords for those unfamiliar. But what we're going to do is not dive into what's a typically traditional language like Java or C++ or C#, catchphrases that you might have heard in the past. But we're going to use a programming environment, a graphical programming environment that was actually developed by MIT's Media Lab. And this is an environment that allows you to program, quite literally, by dragging and dropping puzzle pieces that fit together logically in a way that lets you implement these things called loops and conditions and Boolean expressions. And you can actually, on day 1, after this Friday, write a program that actually some of your friends might care about. So in yesteryear, or when you've taken, say, a computer science course in high school, odds are one of your first programs was the equivalent of Hello World. Like, wow, Mom, I just made the computer type some characters on the screen. It's a very underwhelming experience. Much more interesting is it to implement a little something like this as one of last year's students did. So I give you the work of a former classmate. It's a love story of sorts about dancing cookies.
the dice, it had to be. The only one for me is you, and you for me. So happy together, so happy together. And how is the weather? So happy together. So
So this was actually from a student who had never programmed before. And just to give you a teaser of this interface, and we're only going to use this for 1 week time, really to get the comfort levels up and to get folks excited about what you can actually make these machines do. This is an environment where you'll be programming by, for at least a week, just dragging and dropping puzzle pieces that fit together, as we'll see, in a logical fashion. And it lets you do fun, if silly, things quickly. And for any of you who are a little bit familiar with things like Java and C++, it's usually a good semester or 2 or 3 before you finally get to start writing something that another person might actually enjoy watching. Well, in week 1 of the course, or the second week, 0 index, we dive into a more traditional environment. In this course, we'll spend much of our time on a language called C. This is one of the earliest languages that, unlike Java, actually gives us much greater access, for better or for worse, to manipulating hardware and actual memory. And we can do a lot of damage with that. In fact, anytime you read of web servers being exploited or computers being hacked into, very often to this day is it the result of people having run software in a language called C or C++ without sufficient care given to what are called buffer overruns or lengths of arrays. So some fairly technical concepts that are not that hard to understand, but there's been a lot of humans making a lot of mistakes for years, and with this language we'll actually understand some of those security implications. But each week, typically, we'll introduce also an interesting domain that will inspire that week's problem set. So we'll also take a look in this week about at the field of cryptography, cryptanalysis, the notion that you can encipher information in such a way that people can't read your messages, but if clever enough, perhaps you can, in fact, crack what are otherwise secret messages. In week 3, we then look at some basic fundamentals of computer science like searching and sorting, and we'll actually look at this notion of recursion, how to debug programs. In short, we'll take things up to the level of problem solving and not so much about mere syntax and implementing short little cookie cutter programs. In week 4, we introduce more sophisticated topics still. What does it mean to manage memory? What does it mean to run out of memory? What does it mean to actually segfault, if you've heard this expression, and odds are you haven't. But very bad things happen, and frankly, by terms end, will you understand terms like my code segfaulted, which actually is generally not going to be a good thing. But then again, we'll introduce some domain-specific stuff. So actually, one of my internships during graduate school was to work for the local Middlesex County District Attorney's Office doing forensic investigations in a digital sense. The local Mass State Police would bring to our office hard drives and floppy disks and sometimes, for unknown reasons, mice and keyboards, and we would be tasked with finding evidence. Now, it turns out, and maybe just an FYI, that the criminals in Cambridge, Massachusetts at least, not necessarily that clever. Very often our forensic analyses boil down to booting the computer up and double-clicking on the My Documents folder, and therein lay the evidence. But what we'll do in this week is actually give you a sense of what it means to store information on a hard drive, on a flash drive, and why can otherwise private information be disclosed to third parties when you drop off a computer to be repaired or when you even discard it. Well, someone might very well be sifting through those hard drives, and it's really not that hard to find data if you know how to look for it. Well, in week 7, we'll look at more sophisticated data structures. Again, tools, techniques that you can use, a la phone books and a la searching huge data sets much more intelligently. And the week's problem set will task you a bit competitively to see just how fast the code you can write is and how little memory you can use. Toward term's end, though, will we take things up to a higher level in terms of programming languages and put C behind us and introduce a web programming language known as PHP, one of the popular languages these days, much of Facebook's Facebook is still written in PHP, at least outward facing. And it's just a very easy language to learn quickly once you already know another. So with PHP, will we be able to solve problems and implement websites that do interesting things? The news site I showed you, the event site, the Shuttle Boy site, all of those happen to be written in PHP, but by no means is that prerequisite. What you'll also find throughout this course is that you're not going to exit this course knowing C. You're not going to exit this course knowing PHP. Those are not interesting skills to claim, but knowing how to program, knowing how to use data structures and algorithms in an interesting way, that's a compelling story. Even I, all these years later, throughout college and graduate school, the only time I ever learned a language was probably in CS50, where it was still taught in C, and CS51, which is one of the successor courses. Everywhere along the way since has been, go learn this language and then work on this problem set. Because computer science is not supposed to be about, here's a language, let's spend 7 weeks teaching you where the semicolons are. There are much more interesting ideas out there. Databases for one, and in this week too, will we introduce you to this query language called SQL that will allow you to actually store information in databases and actually implement some fairly interesting final projects. The week after, will we look at what's called client-side programming, doing interesting things on a user's computer, taking advantage of their CPU cycles, doing things a la Google Maps and these websites that actually use JavaScript, which is a language we'll introduce to let you do client-side things, make more interesting, more sophisticated user interfaces, but that at the end of the day have to be really mindful when implemented of a lot of sticky issues like network speeds and network performance and security. So it's not about, again, just coding something up that's fun to use or pretty to look at, but actually thinking about the design that'll be the interesting process. And then the end result aesthetically will be often a really neat toy to show yourself or a friend. And then we'll look a little bit at hardware. We're going to take for granted that there are these physical boxes throughout much of the semester that will do what we tell them to do. But how are they doing that? So we'll actually take a peek underneath the hood and talk about what a compiler really is, what a CPU really is, and actually consider what's making all of this fanciness from stupid YouTube videos on down possible. So what are the expectations? Attending lectures and sections, completing 9 problem sets assigned roughly weekly, 2 quizzes, a final project, and there is in fact no final exam. Grades, it's always a question, broken down as follows here. You can take the course pass-fail, but let me say here, and I'll be happy to say it as many times, I personally care relatively little about grades. I think they are a wonderful, well, they are a useful pedagogical tool with which to motivate and unfortunately sometimes demotivate, but you'll find in this course that at the end of the day, it's more about seeing how far you can go from week 0 to week 12, as we say in the syllabus, than it is about absolutely ranking all students in this course. So if you're coming into this course among those less comfortable, though a large demographic, do not assume that that's automatically putting you, say, in the lower third of the so-called distribution. At term's end, do I sit down with the TFs and discuss each and every one of the students? We take into account the where a student came from, what kind of trajectory they were actually on. And so at the end of the day, please focus more on, and I don't mean to sound too grand, the process of learning and less on the numerics. And you'll actually see that we grade problem sets in particular very coarsely, whereby along 3 axes you will get a score of 1, 2, 3, 4, or 5, where 3 is in fact good. 3 is not C. 3 is good, 4 is better, 5 is best, but more on that as the problem sets are released. So the course's website is where you will find, as in most cases, a whole lot of useful things, if not silly things too. And we have the luxury as computer scientists of implementing it ourselves. So over the course of the semester, will you see various new features rolling out. You'll find over the course of the semester that the bulletin board is a wonderful place, certainly in a course of this size, to turn when you have questions about the problem set, questions about some computer science concept. You'll be able to check your grades, download all handouts in advance of lecture typically while I post the slides if you're the type who wants to scribble on notes. But as you've seen, usually I shy away from long lists of detail and more pictures of cats and other visual cues. So you'll find too that we will often provide printouts of code when we actually think it particularly advantageous to write right on the paper. Software videos will be available usually around 1 to 2 to 3 days maximally after each lecture. So the courses are being filmed and every lecture will go online in various formats, including QuickTime and MP3s for downloads to iPods and such. And also will you find a link to what we call the virtual terminal room, which as you'll see is related to virtual office hours. Books are expensive in the computer world and also not that useful. They are on reserve, or they are on the shelves of the coop. Although we're told that last year they ordered like 120 books for the course and 30 were actually purchased. But this perhaps speaks to the fact that there exist places like Amazon.com. So if you are the type who actually enjoys the sort of support structure that a book provides, if you like to read up more than, say, the course's typical materials offer, by all means, procure one or more of the books that we recommend here and discuss it more in detail in the syllabus. But realize there are so many resources that this course provides in printed form and electronic form. And my God, there's the whole internet out there. Books are not something that are required for this particular course. Lectures in general will be Mondays and Wednesdays, except for this Friday and next Friday, simply because of shopping period and Labor Day. So we'll next meet this Friday, next Wednesday, next Friday, but thereafter this is just a Monday, Wednesday course. So this little visual cue here is to remind me that yes, we do distribute videos in QuickTime formats, MP3s, fun ways that you can, if you're actually this type, maybe in the 14%, watch a computer science lecture on your iPod. But it reminded me of the fact that at term's end last year, the course culminates in final projects for which students can design most anything they want. And we actually had some students tackle iPhone applications. One of these, at least, is now in the Apple Store. It's called Rover. It's been adopted essentially by Harvard student agencies. And it's the iPhone version of the unofficial guide to life at Harvard. They did a brilliant job. I bring this slide up, too, just to point out what other technologies might very well be down the road. Some of you may have seen this before, but just to give you a teaser of apparently what's in the pipeline, I thought I would offer this brief distraction here.
Laptop computers. With the MacBook wheel, Apple has replaced the traditional keyboard with a sleek, touch-sensitive click wheel. Apple CEO Steve Jobs introduced the product yesterday at the annual Mac Expo. Senior product innovator Brian Gilman says the MacBook wheel will make typing a thing of the past.
At Apple, our philosophy is create products that are simple to use, and nothing's more simple than a single giant button.
Gilman showed me how the revolutionary new computer works.
Just open the Intuitype alphabet menu here. Scroll to the letter you need, see? And center click to select it. Then click again to capitalize, and repeat this process for each new letter. It couldn't be simpler. You can also let the predictive sentence technology complete the sentence for you.
Gilman says the MacBook wheel has also simplified the organization of files, so searching your hard drive will be a snap.
Just press both sides of the wheel concurrently and center click, and there you have an alphabetical listing of every file on your hard drive. Everything is just a few hundred clicks away.
Apple is calling the MacBook wheel the most intuitive product ever designed.
Here at Apple, we like to think that we're giving customers features they don't even realize they want yet.
While the MacBook wheel won't hit the shelves for another 3 to 15 months, many Apple users already have it on their wish list.
I'll buy almost anything if it's shiny and made by Apple.
Alex Zalban was one of the lucky few to get to try out a Mac wheel and spent 45 minutes typing an email to his friend.
I never really realized how much I hated keyboards until I saw this thing. I like how the email automatically says sent from a MacBook wheel. That way people know you have one.
With a price tag of just under $2,600 for the lowest end MacBook wheel, it is an investment. But the super thin laptop features numerous innovations like the new ultra thin Hummingbird battery, which can power the MacBook wheel for a full 19 minutes before needing to be recharged. And the computer is virtually unbreakable unless dropped or hit. But Apple isn't resting on its laurels. Brian Gilman said they are already hard at work on the next generation of the MacBook wheel, which will be 4 ounces lighter due to its lack of screen hard driver wheel. For the Onion News Network, I'm Jeff Tate.
Thank you for that, Jeff. It remains to be seen if the wheel will catch on in the business world where people use computers for actual work and not just dicking around. Moving on, police warn...
So I've seen that thing probably a half a dozen times now, including once at like 2 a.m. last night, and I was scrolling down on YouTube, and like literally an hour prior, some guy had in all seriousness posted, "Just a wheel? That's the stupidest product I've ever seen." And then the rants ensued on the thread thereafter. So besides lectures, there are also sections. And it is your teaching fellow and the course's course assistants that you will get to know very well over the course of this semester. Sectioning won't begin for a week or so's time. More on that in the lectures to come. But know that the course will have several different tracks of sections, much like First Nights has for music. Sections targeted more at those less comfortable, those more comfortable, and those somewhere in between. And what we also offer most Sunday nights before a problem set is due on this following Friday is what we call code walkthroughs, where one of the course's teaching fellows will lead a session targeted specifically at the week's problem set and will help you answer the question, where do I begin? How should I approach this? And that too will be filmed and made available online and always linked on the course's website. So this course has a huge staff. Our staff is larger than Harvard's average class size. We have over 50 people involved in the production of this course on a weekly basis. Some of them teaching fellows who hold sections, grade work, hold office hours and more. Course assistants who are former students who are offering on a volunteer basis, in fact, multiple hours of office hours in the computer lab per week. System administrators, folks doing all of our AV and video production, someone who will actually be taking notes for you. So it is actually my opinion that scribbling down most every word someone like me says is not a very good use of one's time. Much more interesting, I think, to actually engage with what's on the screen, what's being presented. And so what we will do as a course is post PDFs online within a couple of days of lectures of scribe notes, which is essentially an authoritative version of course notes, unedited, but rather documenting what went on in lecture that day, thereby hopefully freeing your minds and pencils from jotting a great deal of information down. We have some of the team here. Most of our team is actually shopping courses, but if a few of you guys would like to come on stage for a moment with our head teaching fellow and assistant head teaching fellow, allow me to ask the latter to say a quick hello. And as these guys come up in absentia, allow me to say that also on staff this year, besides the folks you see here, are Alex, Alice, Andrew, Batul, Charlotte, Chris, Dan, Daniel, David, Derek, Dev, Dee, Doug, Drew, Erica, Phil, Glenn, Greg, Janice, Jason, Jean, Jeff, Jesse, John, Jonathan, Jordan, Josh, Kareem, Kelly, Ken, Kent, Hubach, Lee, Madura, Marta, Matthew, Michael, Michelle, Mike, Nathan, Patrick, Peter, Peyton, Rose, Saba, Sanjay, Shannon, Stacy, Ted, Welly, Yair, and me. So our course's teaching fellows and course assistants, Jansu and Yuki, would you like to say a quick hello?
Hi. It's definitely a great honor to be back here for the third time. And if you're one of those who are like less comfortable, can I think I can project my one. No, apparently not. If you're one of those less experienced, or if you have no experience whatsoever, there is no need to be afraid. I walked in here 2 years ago with no experience whatsoever, and I thought that I was like down there, and that I was sure that I was going to fail the class. And well, I came back for the third time. I did not fail the class, but this course is great because it has such a good community. As you can tell by the names listed by David, all your TFs are here and CAs are here to help you. So if you have any questions at all times, just come up to us. And not taking this class just because it's hard is not a good excuse. So, hi.
Hi. So, yeah. Well, both as a student and TF, I've really enjoyed being part of this course. And even though it's the kind of course that requires a lot of work from you, we put a lot of work in it for you as well to make it as enjoyable and fun as possible. So we really hope that all of you stay and take part in this very special experience.
Thanks. So you will find, thank you to all of you. You'll meet them in the hallway in just a few minutes as well. So you'll find that this course, perhaps more so than many, is a very much shared experience. This is not a competitive course. This is not your pre-med course. This is a course which ultimately, yes, is about doing independent work, as you'll see each week by way of the problem sets. But you can't help but get close to someone when you're fighting with some bug and banging your head against the computer screen proverbially to try to track down some bug. And I think you'll find that past students will concur that you exit this course with both a lot of friends among students and also on staff. So where does that happen? Well, within office hours. In the basement of the Science Center, there's some large computer labs, and we pretty much take them over 5 nights a week. These won't start for some time, and this, to be honest, is perhaps the most beautiful picture of the Science Center I've ever seen. It does not look like that on the inside. But it is a place where a good percentage of students do choose to spend time to get one-on-one assistance with each of the week's problem sets. Each week we will offer more than 100 person-hours of assistance one-on-one in the Science Center per the schedule that will eventually go online. And for those of you who live, say, in the Quad or in Mather, or who just don't want to trek all the way to the Science Center to ask that quick question, we also offer what are called virtual office hours. Much like remote technical support, will you be able to log into a glorified chat room in which, yes, you can type back and forth with a TF or CA, but you can also share your screen or share control of your mouse with them subject to your consent so that they can help you troubleshoot any problem or any question you have remotely. To give you a sense of what's involved in the course, these are statistics from last year. So you will, I think it's quite fair to say, work your ass off in this course. But per my promise from the start, this is one of those experiences that I don't think a typical student regrets. If you flip through, for instance, the Q Guide forms that are all on the course's website, you'll find that only by putting in the time to a course like this do you really exit having felt like you got something out of it and, frankly, might very well have emerged even smarter. So what does it mean to actually write programs and implement problem sets? Well, the first problem set last year, a quick retrospective here, was to implement your very own program in Scratch. And we spend just the first week there, and the goal is to implement your own game or animation or art or anything that appeals to you. In week 1, do you then implement some basic C programs to get acclimated to a more traditional programming environment at the command line, at Linux, so you get comfortable with some of these basics that will certainly serve you well in the long run. Last year's problem set 2 was about cryptography. We gave students the opportunity to implement some ciphers, algorithms that let them encrypt information, and we also offered some students the opportunity to do the opposite. Many problem sets are offered, as you'll see, in 2 editions. A standard edition that we expect almost everyone to do, say 90% of the class, and then a hacker edition, which presents the material from a more sophisticated angle, expects perhaps a bit more clever work from those more experienced. And for this one, did those students get handed in the hacker edition pre-existing usernames and passwords in encrypted form, and they had to figure out what those passwords were. We actually got a little in trouble for this 2 years ago because all of a sudden FAS Computer Services saw like 50 people running a crack program on nice.fas.harvard.edu, so they now have been given a heads up for programs like that. Last year, students implemented the game of 15. Not all that much fun to play as a party favor, moving the numbers up, down, left, right, but a really stepping stone to implementing something interactive that involves a human. And the hacker edition for this one had students implementing God mode, which actually solved this thing for the human. Maybe cheat mode, perhaps, is the more apt term. And then Sudoku, which was a step up toward that, where we provided the students, with a framework, with a whole bunch of code that you needed to first understand before taking things the final mile and implementing some of the remaining functionality. And then we dabbled in forensics. And this grew out of a real-world experience of between me and a friend. For this problem set last year, this buddy and I, he being a particularly good photographer, strolled around campus and we shot photographs of unique but non-obvious but identifiable places on campus. And this was using his digital camera. All these JPEGs got stored on a compact flash card or whatnot, and then I accidentally formatted the thing, erased it. Well, it turns out formatting something, erasing something, usually means neither. It just means doing a little bit of work to make the human think their data has been erased, but in reality, it really hasn't. It's just been forgotten. And so we tasked last year's students with writing a program in C to actually recover these photos for my friend. We gave everyone a forensic image, so to speak, a big file representing that compact flash card, and they had to recover the several dozen photographs. And they also had to solve this little murder mystery. We provided folks with this image here. Those of you who might have seen this before might be doing that squinting thing right now where you're trying to look through the picture. Well, you look pretty awkward because this is not a magic eye puzzle. This is just random red noise that actually has behind it an actual message. And it turns out that I think it was Colonel, let's see, I got my little solution here. Last year it was Colonel Mustard in the study with the candlestick. And this was the murder message recovered by students who wrote code to do so. And then in problem set 6 last year, we challenged students with implementing the fastest spell checker possible. And what do we mean by that? Well, we handed the students a big text file containing 140,000+ words, English words, and we said, write a program that loads all these words into memory, but very quickly and very efficiently can tell us, yay or nay, is this document perfectly spelled or are there errors? And what we provided was a testing framework, a harness, that students, if they wanted to compete, could run their code against some benchmarks, against some testing programs that we wrote, and then ranked on the course's website from fastest to slowest were the running times, the amount of time it took for each student's code to actually execute. Completely opt-in. It's by no means required. And we took a bullet for the team and made sure that one of our own teaching fellows, intentionally I think, was at the very bottom of the list. So there was definitely a lower bound. But the funny thing was, and we saw this in the Q Guide evaluations, this problem set of all things was apparently the one that people sunk the most time into, not because it took any longer than all of the other P sets, but they would come back from like dinner, look at the board and realize, damn, my friend, my roommate, just ever so slightly inched higher than me. And so it incentivized people, if only to one-up their friends and roommates. In problem set 7 last year, we asked students to implement their own E-Trade-like website, whereby you had to create a website using that language called PHP, a database called MySQL, that actually lets people log in and then manage a portfolio of stocks, buy stocks, quote unquote, sell stocks, quote unquote, get stock quotes. And from where? Well, we had the students patch into Yahoo Finance, where they grabbed nearly real-time stock quotes to actually simulate the process of buying and trading stocks. Unfortunately, some students, perhaps some economics majors or just folks with too much free time, figured out last year how to game the system. So even though we gave everyone 10,000 virtual dollars, I think our winner turned teaching fellow this year, actually, right? Don't push them away. Make them one of your own. $4 billion, something like that, ridiculous. Turns out we weren't really checking whether or not people were trading after hours. And it turns out that also Yahoo's stock quotes are not, in fact, perfectly real time, which means if you just have a real E-Trade account, you can see the future and see where the stocks are going. So apparently you can exploit that if you put your mind to it. And then in problem set 8, the course's final problem set last year, did we have students implement a mashup where they took Google News and Google Maps and mashed them together using JavaScript, PHP, and SQL in such a way that they had a website that they could find all of the local news from, whether it's zip code 02138 or 90210, and you would actually pull the local current event articles via this thing called XML and integrate it into the view of a Google map. And then, at very course's end, was the true climax of the course. This course culminates in final projects, which ultimately will be your opportunity to design your very own piece of software designed by you or 2 or 3 friends. And the course then climaxes with the second annual Computer Science 50 Fair, which last year was an exhibition across the street in one of the engineering buildings with 300 laptops atop tables. Popcorn was popping, music was playing, stress balls with CS50's logo were being thrown around. And this was an opportunity for our 300 plus students to exhibit their final projects, not only to each other, but also to some 900 attendees in total. And we also invited some recruiters as well. So that is what you have to look forward in this course. You also have cake to look forward to in the hallway. This is CS50, and we will see you on Friday.